So we're jumping to chapter 8, which goes back to trigonometry, but in this chapter you'll be using your calculators to solve the trig problems. Section 8.1 is a review of right triangle trig and should be a good way to get started for the beginning of fourth quarter. This is going to be a short video, and then you're going to do an assignment on delta math today. You will need a calculator to do this. Just a quick review, when we're looking at a right triangle and we want to find the exact values of the 6 trigonometric functions, we need to know our basic trig ratios, SOHCAHTOA, and then we need to know which functions are the reciprocals of which. So in this triangle, before we do anything, we have a leg that's 6 and a hypotenuse of 10, so we should know that the other leg is 8. You could always do Pythagorean theorem if you didn't recognize that. It just says find the exact values of these functions, so we're looking for the ratios. Sine of theta. Sine is opposite over hypotenuse, 6 over 10, and we're going to reduce these whenever we can to 3/5. Reduce the fractions, write things in simplest radical form, and so on. Cosine of theta, adjacent over hypotenuse, 8/10 is 4/5. And tangent of theta, opposite over adjacent, 6 over 8 is 3/4. And then we should know the reciprocal functions. Cosecant is the reciprocal of sine, so it would be 5/3. Secant is the reciprocal of cosine, so it would be 5/4. And cotangent is the reciprocal of tangent, which would be 4/3. Again, there's kind of some basic things that we need to remember and know. We should know SOHCAHTOA. We should know which function is the reciprocal of each of the 3 original trig functions. And then there's a couple other identities that we should be familiar with. We have the quotient identities, which say that tangent of theta is equal to the sine of the angle divided by the cosine of the angle. And then its reciprocal, cotangent, is equal to cosine divided by sine. We saw all of these back in chapter 6 and 7. And for the Pythagorean identities, there were 3 different forms, but the one that I do want to make sure you're familiar with is sine squared of an angle plus cosine squared of the same angle is always equal to 1. We proved why all of these work earlier in the year. So in this section, you're going to do some solving of a right triangle. Solving a triangle means finding all the missing sides and angles. In the delta math, it only may ask for one side or angle at a time. And with right triangles, you can find everything that's missing if you know 2 sides or an angle and a side. When you are doing this section and all of chapter 8, make sure that your graphing calculator, whatever calculator you're using for homework, is in degree mode. So for example here, I want to solve the triangle. And one note, when we're looking at triangles throughout this chapter, the names of the vertices are the capital letters. So this is triangle A, B, C. And then opposite of each angle is a side that is named with the lowercase letter, the same letter. So here, side A is opposite angle A. Side B is opposite of B. C is opposite C. And with a right triangle, C is always the hypotenuse. So in this problem, B, the length of this side is 2, and A is 40 degrees. When we're solving a right triangle, the first thing we can start with here is to find the measure of the other angle. Angle B would be the complement of angle A. Angle B must be 50 degrees. And then we're going to use trig to find the lengths of the sides. We know that B is 2, and we could use either the 40 or the 50 degree angle in order to solve for A and to solve for C. If I want to find A, let's use the 40 degree angle. A is opposite of the 40, and the length of 2 is adjacent to it. So opposite over adjacent, tangent of 40 has to be A over 2. I'm going to multiply the 2 to the other side. And then I would just put this in my calculator. And again, this is a good place to check and make sure that you are in degree mode. Your answer should be a length of 1.68. Obviously, this triangle is not drawn to scale. 40 degrees is less than 50 degrees, so the side opposite of it should be less than 2. Then we want to find the length of side C, and you could use Pythagorean theorem at this point, but try to avoid using rounded values in your calculation. Instead, I'm going to look at, I have the 40 degrees, side of length 2, and then C is the hypotenuse. So 2 is my adjacent side. I'm going to use cosine of 40 equals adjacent over hypotenuse. And remember that when you're solving for the variable in the denominator, I'm going to multiply both sides by C, and then divide both sides by cosine of 40. And then you would put 2 divided by cosine of 40 in your calculator, and C should be 2.61. And the hypotenuse of the triangle should always be the longest side of the right triangle. Here's another example where in this case we're not given any of the angles other than the right angle, but we have the 3 and the 8. The 8 is the hypotenuse, and 3 is one of the legs, so I can use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 3 squared is 9, so b squared is 64 minus 9 is 55. I'm going to take the square root of 55. Leave your answers in simplest radical form unless you're told to round. Then we have options for finding A first or B first, and once we find one, we can subtract from 90 to get the other. If I want to find the measure of angle A, I could use any combination of these 30 side lengths. For example, I could say that the sine of A equals opposite over hypotenuse equals square root of 55 over 8. Or I could say the cosine of A equals adjacent over hypotenuse equals 3 over 8. Both equations should get me to the same answer. When I'm trying to solve for an angle, we need to use the inverse trig functions. So here, it would say A is the inverse sine of square root of 55 divided by 8. Or A is the inverse cosine of 3/8. And then I'm going to go to my calculator, and again, it's in degree mode. And if I take one of those, inverse cosine of 3/8, for example, I get that the measure of angle A is 67.98 degrees. I'm going to have you go to 2 decimal places for all of these. Once we have angle A, we can take the complement of that, and we'll get that angle B is 22.02 degrees. So we've solved the triangle because we found every missing side and missing angle. This material should be a review. We'll do some applications with the trig functions and some other problems tomorrow. But for today, sign into Delta Math, and there is an assignment that says review of right triangle trig that you need to complete.